Hello, I'm experimenting with something new. I'm trying to record with Cisco WebEx, and I think that you can see my screen here. And I want to talk about page 8 in the tutorial here on lesson 5.1. It says, let's review the key features of a quadratic function by examining its parabolic graph. Notice that the shape of a parabola is a symmetric curve. So first of all, a quadratic is a U-shaped curve. So it's the blue curve right there in the picture. And there are a bunch of parts to this U-shaped curve. By the way, the program frequently calls this a parabola. It's quadratic and parabola mean the same thing. They are a U-shaped curve. And first of all, the vertex is at number 1 there. I think you'll be able to see my arrow. There's the vertex. It's either going to be the highest point on the curve or the lowest point on the curve. In this particular case, it is the lowest point on the curve. So it's going to be called a minimum value. If it happened to be an upside down U for the quadratic, then we would have a high point on the graph for the vertex, and that is called a maximum. The axis of symmetry is this green dotted line right down the middle of the graph. And what the axis of symmetry does is that it divides the graph in half. So what I can see here is this point 2 on the graph is 1, 2, 3 spaces away from that green dotted line. If you count 1, 2, 3 on the other side of the green dotted line, you will have a point. It works down here at 0, 8. 0, 8 is 1 space away from the green line. On the other side, 1 space away from the green line. If you fold that graph hot dog style, the right half of the graph will land on the left half of the graph or vice versa. The axis of symmetry is a line, and it's always going to be x equals something. The intercepts, number 3. Well, the intercepts are the x-intercepts, which is where the graph crosses the x-axis, and the y-intercepts, where the graph crosses the y-axis. The x-axis in this particular, the x-intercepts in this particular picture are 2 or 2, 0 for the ordered pair, and -4, 0 for the ordered pair. It's where the graph crosses the x-axis. Those are also called roots or zeros of the function, which the tutorial will talk about later on in here. The y-intercept is down here at 0, -8. It's again where the graph crosses the y-axis. The end behavior, I want to come back to in a minute. I'm hoping that I can show you with my document camera what the end behavior is. But the domain and range. In the domain of all quadratic functions, and the key word there is functions. It has to be a function. The domain of every quadratic function is all real numbers, which is -infinity to +infinity. And the range is going to be either it's the lowest point to infinity or the highest point, or -infinity to the highest point. I'll say that better. The domain, again, are all the x values on this graph, and they're all real numbers, -infinity to infinity. The range in this particular graph is the lowest value, which is down here at -9, up to infinity. Our graph keeps going up, 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 up. So it turns out that I cannot show you this picture on notebook paper and talk about the end behavior. So I will have to direct you with my arrow on this. I can see that I have it in the corner of the screen there, but I'm going to unplug that because that's not going to help you. But what's going to happen here is that the end behavior, you start at the left side of the screen. And coming from the left side of the screen, what's happening on the graph is that you would go down, 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 down. You go in the downward direction, as you see, and from the graph is going to be decreasing, which you can't see that I'm writing in the corner here, but it's going to be decreasing from negative infinity to the x value of the vertex, which is -1. And then when we get to the very bottom of the graph here, then we start going up, 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 up. And then that says the end behavior there, it's an increasing, and I've kind of gotten off track here a little bit, but it's increasing from -1 to infinity. But the program, what it really says is, it says as x approaches infinity. So if we say as x goes towards the right, what's happening to our graph? Well, our graph is going upward. So as x, so the end behavior is as x approaches infinity, and the approaches is represented by an arrow going to the right, then our graph is going upward. That's what that red arrow is. So as x approaches infinity, then y approaches infinity. If you go the other direction, as x approaches negative infinity, so it's the purple arrow going towards the left here, then what's happening is our graph is going upward still. So as x approaches negative infinity, our graph is increasing as well.